guys, welcome to Not So Nerdy channel. So let's try to understand what backtracking is. I hope you have gone through the recursion video. So what is a backtracking? Backtracking is a methodical way of trying out various sequences of decisions until you find the one that works. Okay, so you try out the paths and you get your result. Backtracking allows us to systematically try all the available avenues from a certain point after some of them lead to nowhere. So from the diagram, you can see that you start from somewhere and then you reach somewhere, but then you find a dead end. You come back, you again go to another path and you find a dead end. So you choose another option, and that's how, like, at every intersection you are choosing a path and then you're coming back, you're tracing another path, and finally you get your success. So this is what backtracking is. Okay, note, recursion involves a function repeatedly calling itself until it arrives at the base solution. So we saw from our recursion video that we saw in the factorial example, we found that we are repeatedly calling the function to get the final result. But in backtracking, you find solutions and like one at a time, and you discard the ones which are less optimal, or if you reach nowhere, if it's a dead end, you try another path. So that's the difference between both of these. So backtracking is also using recursion, but for a different purpose. So where can you use backtracking? It always return to a position which offers other possibilities for successfully solving the problem. Okay, so here are the examples. Most famous ones, like you can solve maze problem, n-queen problem, graph coloring problem, Hamilton cycle, subset sum problem. Okay, don't get overwhelmed by these. You'll get to know in my future videos about all of them. Suppose like you have a maze, right? And you want to reach at some point. So you start from 0 and you take a path and you find a dead end. So what do? You trace back, and then you trace till the intersection, and then you follow the other path, right? So I hope you are getting a clear picture of what backtracking exactly is. Let's try understanding with n-queens backtracking problem. So it is one of the most common example of backtracking, and our goal is to arrange n queens on an n cross n chessboard. So you have, suppose, 8 cross 8 chessboard and you have 8 queens. So you have to arrange those 8 queens on the chessboard such that they do not strike each other down. Like we know that a queen can strike another queen which is placed horizontally, vertically, or diagonally, right? So you have to have those paths cleared. There shouldn't be any other queen on the same path of other queen. Okay, great. So okay, so you have a 4 cross 4 chessboard and you have to place 4 queens, right? So we start placing from first position. I'm not giving a code solution here. I'm just trying to make it more clear for you. So you start by placing 1 queen here in the first row. And now you know that this is blocked. This is blocked, like this column and this row is blocked and this diagonal is blocked. So you have 5 other places to keep, like 6 other places to keep your queen, right? So place the second queen in a safe position, and we can't put the queen in the first row, column, and diagonal. I forgot to mention here. Okay. So now we have to place the third queen in such a way that none of the queens are disturbed. Like it cannot be placed in this diagonal area or this diagonal area or this, and this, right? So you have like a few boxes left where you can place your queen. But now you see that we can't place the 4th queen anywhere. Like we are stuck here. We do not have any other option to place the 4th queen without getting attacked. So you backtrack. Okay. and then you backtrack to some place to like you go all the way or you go till the second last. So now let's position the second to another position. We can shift the second one, right? And you shift, last time you placed here, but this time you're placing it here. Okay. Again, we can't place the queen here, so it will go to the previous state. Again, you are failing to find a place where you can place your fourth queen. So like every box is blocked, and after backtracking a lot of times, you finally get your result, and this will be the final solution. You backtracked all the way to your first queen and have to change its position to the second column, right? Okay. So I didn't discuss about the code here. We'll be solving problems related to it, and I'm covering this here because a little understanding is required before we move with further questions. Okay. So let's try to understand. Okay. Okay. What are the advantages and disadvantages? So backtracking can almost solve any problems due to its brute force nature, right? It can be used to find all the existing solutions if there exists for any problem. It is a step-by-step representation of a solution to a given problem, and that's very easy to understand, to follow up, right? And very easy to write the code and also to debug. But there are like huge disadvantages as well. Like it's very memory intensive, time consuming, and we don't really want that. And it can become like stuck at infinite loops as well if we do not have a proper like a code base, right? So these are a few advantages and disadvantages. We will be solving problems related to it in the near future, so you'll get more clarity. Meanwhile, you can check out my previous video based on recursion. And yeah, thank you. That's it. Bye-bye.